Exercise 10.3. Now we continue with the question number 9. There you are asked to find the angle between two lines. You are given the lines here, so we write their slopes. What's the slope of the first line? Minus a by b. Minus a by b, so it will be minus root 3. And here minus a by b, that is minus 1 upon root 3. You know, slope for the line ax plus by plus c equals to 0. If you are given this line, then the slope is given by minus a by b formula. We already discussed coefficient of x upon coefficient of y with minus sign. Okay. Now we let's take alpha be the angle between two lines. Angle between two lines. Measure of angle between two lines. So you know this tan alpha, or you can write theta also, that's not important, equals to modulus of m1 minus m2 upon 1 plus m1 m2. This is the prepared formula we have for the angle between two lines. Okay, just place the value here. What is m1? m1 is minus root 3. So this will be plus 1 by root 3 upon 1 minus minus will be plus. So this remain plus only, root 3 into 1 upon root 3. Okay. Now just simplify here. So what we'll get from this? If I take LCM, this is minus 3 plus 1. So minus 2 by root 3 upon, this is just 2 because root 3 will get cancelled. So we are getting just 1 by root 3, tan alpha equals to. And you know forward value of alpha, tan alpha becomes 1 by root 3. That is alpha equals to, you can write pi by 6 or 30 degree. 30 degree, pi by 6 or 30 degree. Normally acute angle is considered the angle between two lines, or you can write these also. You can see if this is 30 degree, then this is also angle between two lines. Then this much has to be 50 degree if this is 30 degree. Normally we take acute angle as the angle between two lines. Or you can take here tan alpha equals to minus 1 by root 3 also. It's up to you. So alpha will be here just 150 degree. It is pi minus pi by 6. That is here 30 degree, there 150 degree. Whichever you write, both are correct. This one and this one. Fine. Okay. The next question. What it says. The line through these 2 points intersect the other line at right angle. Find H. Okay. Right angle means what? They are perpendicular. You are given two lines in the question number 10 which are perpendicular to each other. Let me take first 2 points as A and B here. So H comma 3 and B as 4 comma 1. And you are given one more line. Line is given by here 7x minus 9y minus 19 equals to 0. So this line AB, this is line AB passes through A and B. And this line, both are perpendicular to each other. That's given to you. So when we have perpendicular, what we have in our mind? The slope of this and the slope of this. If you take their product, must be minus 1. And m1 into m2 equals to minus 1. That is what you are going to use here. Product of the slopes equals to minus 1. So get the slope of this. You know how to get slope of this one. How do we get the slope of this one? By which formula? Slope I'll call the m1, y2 minus y1. So minus 2 upon 4 minus h. 1 minus 3 upon 4 minus h. What is the slope of the other line? Minus a by b, 7 by 9. Now use which concept? m1 into m2 equals to minus 1. So we'll get the value of h. Okay, that one, this much only. Slope of this one is minus a by b, 7 by 9. B is minus 9. What about the slope of AB? 1 minus 3 minus 2 upon 4 minus h. You are given 2 points, so you can use y2 minus y1 upon x2 minus x1. So this much you can do. The next question, question number 11. In 11th question, what is asked? Get the line through the point x1, y1. So you are given a point. Now whenever you are asked get the line, then immediately we must have point and slope normally. You have two different points. Okay. So you are given a point here x1, y1 and parallel to one line. Okay. So first write the slope of ax plus by plus c equals to 0 is minus a by b. Minus a by b, you know. So therefore slope of required line is also same. Slope of our line is equals to minus a by b. Why? Which concept? Parallel. So the slopes are equal. Whenever two lines are parallel, you know the slopes are equal. m1 equals to m2. Right? It's like this. For example, this is a given line and this is our required line. Given and required. These two are parallel and this passes through this fixed point. So you have a point, you have a slope, point and slope. So you can use the point slope form. So required line is y minus y0. y0 is y1 here. Equals to slope minus a by b into x minus x0. What is that? x1. So just simplify here. So your b into y minus y1 equals to minus a into x minus x1. So that's just your required equation. If I rewrite equals to 0 form, which is required equation of the line. Fine. You have used simply point slope form. Okay. Question number 12. What it says? Read the question. Two lines passing through the point 2, 3. Okay, so we have two different lines. Both are passes through 2, 3 like this. So you have one fixed point on both the lines, right? One fixed point on both the lines you are given. That is this. This is x0, y0 for this line as well as for this line. Okay. Intersect each other at 60 degree. Okay, so this measure of angle is 60 degree. This is given to you. In short, measure of angle between two lines you are given, right? If the slope of one line is 2, okay, so I'll take this as m1, which is 2. One line. Find the equation of the other line. So we want the equation of the second line, equation of this line. That's the question. So what I need to get the equation of the second line? See, one point on this line is given 2, 3. Now just I need to get the slope. If I get the slope of the second line, I have slope, I have point, so I can get the equation. It is today's session first question. But you see here, you got the angle. You were given both m1 and m2. This is m2. Okay. In this question here, you are given this angle and one m1 is given. So you can get the m2 by the same formula. Got it? We are going to follow these only. So you'll get the m2. You are given one slope. You are given angle. You want to get this. This is a question. Once I get the m2 here, slope of the other line, let's call that as m2. Once I find the m2, I'll have slope, I have point. So I can get the equation of the other line. Okay? That's all in all about the solution. Okay, so let's try it here. You are given as per our notation alpha equals to 60 degree. Alpha equals to 60 degree. Let the slopes be m1 and m2 of the lines. So here m1 equals to 2. So first what we do? We find m2. That is our task. Point is also given. What is point? Fixed point 2, 3. Right? This much we are given. You know now what I want to do. I'm sure you must have understood the entire solution. You are asked to find equation of the other line. If I want to get the equation of the other line, I need to get what? I need to get the slope of that line. How do we get the slope? So slope is by that formula. Which formula? Formula would be what in that case? Tan alpha equals to that formula. So that is what we want to do here. Okay, so let's do that. We'll start with the tan alpha formula. We just place the value of m1, so we'll get the value of m2. Okay, so here tan alpha equals to yeah, tan theta, whichever you write, m1 minus m2 upon 1 plus m1 m2. Okay, so this will be, alpha is how much? 60 degrees, so this will be root 3. I'll write directly. What is m1 here? m1 you know 2, m2 I want to get, so this is 1 plus 2 m2. Okay, now drop the modulus, so we'll have true possibility, plus or minus. So root 3 equals to 2 minus m2 upon 1 plus 2 m2, or minus root 3 equals to 2 minus m2 upon 1 plus 2 m2. Fine? Okay, now question is just simplification. Why plus or minus? You know, because of the modulus. Okay, let's simplify. So here root 3 plus 2 root 3 m2 equals to 2 minus m2. Okay, so here, over here, what we'll get? Let's take m2 over here. Fine, so 2 root 3, I'll take m2 common, plus 1 into m2, taking minus term on the other side and taking common. And this is 2 minus root 3, taking that constant on that side. So what is m2? 2 minus root 3 upon 1 plus 2 root 3. This is one possibility. Go for this. What we'll get here? Same procedure. This is simple algebra. Minus root 3 minus 2 root 3 m2 equals to 2 minus m2. Okay, I'll take this one on that side, 2 over here. So this is minus 2 minus root 3, and I'll take m2 common here. So 2 root 3 minus 1 into m2. So what is m2 from this? Minus, if I keep outside, 2 plus root 3 upon 2 root 3 minus 1. Okay, is this correct? Or you can just write if you want here. Okay, let's keep in this form. Okay, so now if slope is this, you know point where 2 comma 3, that you know point you are already given, so we'll get the equation. This is slope, this is point. Okay, so the equation is here. Equation is y minus y0, which is 3. Slope is this 2 minus root 3 upon 1 plus root 3 into x minus x0, which is 2. Okay, so we just simplify. So what we'll get here? We'll get from this 1 plus 2 root 3 into y minus 3, and this is minus 6 root 3 equals to here 2 minus root 3 into x. Here, what about this? This is 2 into 2, which is 4, and plus 2 root 3. Fine. This is minus and this will be plus. Okay, so we'll express, you know, in that form. Which form? Ax plus by plus c equals to 0. I'll take this one over here. So minus 2 minus root 3 into x. This one as it is. 1 plus 2 root 3y. And what about this? Over here. At this place, I'll take this one on that side. So minus will be plus here. So you have minus 1. And this will be minus 2. So minus here 8 root 3 equals to 0. You can just merge this minus with this. So root 3 minus 2 into x plus 1 plus 2 root 3y minus 1 minus 8 root 3 equals to 0. Right? Now it is in which form? Ax plus by plus c equals to 0. This is a required line in this case. right? Now for the other case, I leave it for you. Start with the same point will be this one only. Just instead of this, you are going to place this. Simplify. So you'll get the equation in the other case, right? This is for you. Do it. That's the other equation. Got it? Understood the entire solution? What we did? You have used just the formula for tan alpha and you got the slopes first. Once you have slope, you can get the equation very easily. Okay, so this is good question. Next. What about next question? What it says? Question number 13, I suppose. 13 number. Find the equation of right bisector, okay, of the line segment joining these 2 points. Okay, so you have a line segment. As I told you here in coordinate geometry, diagram help us a lot. This is 3, 4. This is -1, 2. You have such line segment. Let me call that as A and B. Now, there are 2 important words used here. Right bisector. You want a line through the midpoint. Bisector means passes through the midpoint and perpendicular to this. So, this is our required line. Right? This is a midpoint here. I'll call that as, for example, M. So M will be your midpoint of line segment AB. Understood? This is our required line L, required line. Which 2 things you are given about this line? It passes through the midpoint. So midpoint will be x0, y0 here. So midpoint of line segment AB. How do we get the midpoint? x1 plus x2 by 2, that is this plus this, which is 1 by 2 once you do. 4 plus 2, 6 by 2. This is now x0, y0 as per our notation. Fine, line passes through the midpoint and it's perpendicular to this. You got the slope. Now there is a perpendicular word. So what I'll do, I'll get the slope of AB and then I'll use m1 into m2 equals to -1. So slope of AB, tell me slope of AB. What is that? y2 minus y1, that is 2 minus 4 upon x2 minus x1, -1 minus 3. I repeat, y2 minus y1 upon x2 minus x1. So this is -2 and this is -4. So it is half. So slope of AB is half. Now perpendicular concept. So therefore, what is the slope of required bisector? Slope of required line? It's perpendicular to above line. So reciprocal with minus sign. Which concept you have used? m1 m2 equals to -1. Parallel hoga to m1 equals to m2. Perpendicular means what? Product of the slope should be -1. So you have a slope now. You have a point. So you can get the equation. So equation of right bisector. Right bisector means what? I repeat again. Right bisector means it passes through the midpoint. Bisector means it passes through the midpoint. And perpendicular here, right angle means perpendicular to this. So you have used this right and perpendicular, both the words, is y minus y0 equals to slope. What's the slope? -2 into x minus x0. Y minus y0. What is y0 here? 3. -2. X minus x0. What is x0? That is 1. So 2x plus y. This is plus 2 here. But if I take on the left hand side, it is -3 and -2. That gives us -5. So final equation is here 2x plus y minus 5 equals to 0. Okay. Let's go to next question. Question number 15. Sorry, 14. That is also a good question. 14 number. In every question you see theory plays very important role. Okay. So let's see what it says. 14th number. Find the coordinates of the foot of the perpendicular from the point. Okay, so you have a point here. -1, 3. Let me call this as point P. So here you have a point. There is a line here. equation of this line is given 3x minus 4y minus 16 equals to 0, and you have drawn the perpendicular from this point P. What's the question? If this is the perpendicular, we want the coordinates of M. Okay, that's the question. PM is perpendicular to the line. Which line? 3x minus 4y minus 16 equals to 0. Right? What is the question? We want to find the coordinates of, we find M. That's the question, because it's the foot of the perpendicular. M means what? Coordinates of M, 2 coordinates of M. Find the coordinates of the foot of the perpendicular from this point to this line. Okay, fine. We find the coordinates of M. So what we'll do, from the diagram you can see that it is a intersection of these two lines. One is this and the other one is this. It is just intersection of these two lines. So what we do, we get the equation of PM and then we solve this. So we'll get these two coordinates. Understood? What is M? It is indirectly intersection of this line and this line. How do we get the intersection point? By solving these two equations. So what we'll do first we get the equation of PM. First we find equation of which line? PM, line PM. So what we need to get, you know the theory. To get the equation of any line, you need a point and slope. Okay, do you know slope of line, this line? Yes, minus a by b, 3 by 4. So we'll get the immediately slope of this. So here, slope of given line 3x minus 4y minus 16 equals to 0 is 3 by 4. Which formula? Minus a by b. Okay, so slope of PM, you can write it easily. Which concept? M1 into M2 equals to minus 1. Product of these two should be minus 1 because they are perpendicular. Parallel, equal, perpendicular, product of the slopes equals to minus 1. Reciprocal with opposite sign. Slope hai, point is already given. Which point you are given? Point is minus 1 comma 3. So this is like x0 y0 as per our theory. Okay, so immediately you have the equation of PM. Equation of PM, line PM. What is that? Y minus y0, which is 3. What is the slope here? Slope minus 4 by 3 into x minus x0. Okay, fine. Now we simplify this. So 3y minus 9 minus 4x minus 4. So we'll get the 4x plus 3y, and here you have minus 5 equals to 0. 4x 3y minus 5 equals to 0. This is equation of the PM. Call this as 2. Call the given line as 1. Now what we'll do? You have these two lines. To get this, we solve these two equations. Which two equations? This equations 1 and 2. Solving equations 1 and 2. How will solve this? Elimination method. 3x minus 4y minus 16 equals to 0, and the other equation is 4x plus 3y minus 5 equals to 0. You know how to solve these equations. How will solve this? You know from 9th standard elimination. You, for example, multiply this equation by 4 here. So what we'll get here? 12x minus 16y minus 64 equals to 0, and you multiply this equation by 3, make the coefficients equal. So 12x here plus 9y, and here you know minus 15 equals to 0, right? Then what we'll do? We change the sign, you know such things. Minus, minus, and this will be plus. So this will get cancelled here. And what about this? Here you have 16 and this is nothing but minus 9. So minus 25y. And what about this? Minus 64 plus 15. So it will be here minus 49. Okay. So you will get the 25y equals to minus 49. Okay. And therefore y equals to minus 49 by 25. This is y coordinate. Now put value of y in any one of these two. So we'll get the x. that I'll leave it for you, do it for you. Put value of y in any one of these two, and therefore the foot of the perpendicular will be this x comma minus 49 by 25. This is for you. You can complete this much. Y coordinate I did for you. Try for x coordinate. Right? What is y coordinate? It will be minus 49 by 25. X coordinate just you can find by placing the values there. Okay. Next question. Question number 15, I suppose. What it says? Question number 15. The perpendicular from the origin to this line meet at the point minus 1 comma 2 to find the value of m and c. That's the question. Oh, right. So you need to understand by diagram, so you can answer it very easily. The perpendicular from origin. Okay. So suppose this is origin. There is a perpendicular from origin to the line. Which line? This line. Y equals to mx plus c. Equation you are given. Mx plus c. This is perpendicular from origin. This is origin, that's given to you. This O, let me call this as M. Indirectly, this M is the foot of the perpendicular from origin, like the previous question. And that foot of the perpendicular also you are given minus 1 comma 2. Right? Read the question. The perpendicular from the origin to this line meet at which place? Minus 1 comma 2. What's the question? Find the value of m and c. Okay, so two unknowns you want to get. One is m and the other one is c. Okay, so obviously two things we'll use here. The first thing is this point is on the line, so it will satisfy the equation. That's the first observation. Okay, so let me write here m minus 1 comma 2 lies on the line, is on the line. The point is on the line. So it will satisfy the equation. So instead of x you put minus 1, in place of y you put 2. So what I'll get? 2 equals to here minus m plus c. This is one equation. Clear? Point is on the line, so it will satisfy the equation. X you can place minus 1. Here y you can put, instead of y you will put 2. So 2 equals to minus m plus c. Okay, so this is one equation. Can you just recall what will be the other condition here? What should be the other condition? Yes, the perpendicular concept. Perpendicular concept you need to use. What? That OM is perpendicular to this line. So slope of this can be obtained very easily. Slope of this into the slope of this. This is a standard form. What's the slope here? M. This is, if you remember, slope intercept form. If you recall, it is which form? Slope intercept form. I'm talking about this. So slope is m here. So slope of this line, which is m, slope of OM equals to minus 1. Okay, so I'll write that. Also, slope of OM into slope of that line, that is small m, equals to minus 1. Which concept? As we have used number of times, m1, m2 equals to minus 1. What is the slope of OM? You can write it very easily. 2 minus 0, which will be 2, upon y minus 1 minus 0, so minus 1, into m equals to minus 1. So m will be just half. Okay, once you know m, you can put just in equation 1. So by 1, 2 plus half equals to c. So what is c? It will be 5 by 2. Okay, two things you have used. One is perpendicular concept. In coordinate geometry, whenever you see the word perpendicular, use m1, m2 equals to minus 1. Whenever you see the parallel, use m1 equals to m2. That's always you need to use whenever you find these two words, perpendicular and parallel. So here m is half, c is 5 by 2. Okay, let's go to next question now. Question number 16. That's also a nice question. Question number 16. P and Q are lengths of the perpendicular from origin to these two lines. Prove that you have this much. Okay. So you are given a line here in the first one. That is x cos theta. It is like ax plus by minus k cos 2 theta, that is plus c equals to 0. It's like ax plus by plus c equals to 0. Point is here origin, okay, that is 0 0, and the distance you are given small p. So which formula you are going to use? Perpendicular distance of a line from the origin. Recall the formula: ax1 plus by1 plus c upon under root a square plus b square. This is what the formula. Perpendicular distance of a point from the line. So this formula we are going to use twice, one for this and the one for the other line. So therefore small p equals to, what is x1 y1 here? 0 0. Got it? So this will be 0, this will be 0. This is like ax plus by plus c equals to 0. Both the terms will be 0 here. So you are left with just this much: 0 plus 0 minus k cos 2 theta. I'm just using this formula. x1 y1 is 0. So this will be 0, this will be 0. You are left with this upon a square b square. Now what is a square b square? Coefficient of x, cos square theta. What is b square? Coefficient of y, which is sin square theta. You know very well, this is 1. Okay, I'll just square it because you see in the proof you need p square. Once you square it, this will be free from the modulus. So you have here k square cos square 2 theta. Call this as 1. Fine. We have used simply this formula. But here x1 y1 is origin, so the calculation becomes easy for us. Now for the other one here, there the line is, which line you are given? There line is x sec theta. So this is like ax, y cosec theta. This is like by plus c equals to 0. Okay, and which point you are given? Point is here 0 0. So it will be x1 y1, same like as you did there. Now here you are given q, perpendicular distance small q you are given. So this is 0, this is 0, 0 plus 0 minus k, your minus k, x1 y1 both are 0, just you are left with c upon root of a square plus b square. So what will get here? Sec square theta plus cosec square theta. Fine. I need q square, so I'll square on both the sides. So q square equals to, this will be free from the modulus, k square upon sec square theta plus cosec square theta. Fine. So I'll call this as 2 here. So we have p square from one, we have q square from the second one. Okay, I'll just place the values there, where? In the expression. So I'll start with this now. So p square plus 4q square equals to, p square you know how much? K square cos square 2 theta plus 4k square. Q square is multiplied with 4. What about the denominator expression? Obviously you need to write in form of cos square and sin square, right? Just do the cross multiplication here. So denominator will be here, cos square plus sin square is 1. What about this? 4k square. This will be sin square in theta into cos square theta. Understood? Cross multiplication, and the denominator of the denominator gives us numerator. Okay. This is simply a simplification. Now this much you know very well. Can you recall this k square as it is? What is this? This is sin square 2 theta, if you remember. Why? You just recall this. What is sin 2 theta? Trigo. 2 sin theta cos theta. Right? You already used number of times in the trigo. 4 sine square cos square, 4 sine square cos square, so it will be square of this. Take k square common, so you have 1, so k square root, that's what you wanted. Fine, we have used that perpendicular distance formula twice here. Okay, next question number 17. We had earlier one question which was just similar to this, but this is about altitude. That question was, I suppose, about median. Yes, that question was about median in the earlier exercises, but here this is about altitude. You have a triangle here, so there's a triangle ABC, or you are given a triangle ABC. This is a triangle ABC. A, B and C coordinates you are given. This is 2, 3 here. Then this is 4 minus 1 and this is 1, 2. Okay. Find the equation and the length of altitude from the vertex A. Okay. So first let's get the equation, then we'll think about the length. Through the vertex A. From this vertex we want the altitude. So like this. Equation of altitude from the vertex. Okay, so I need this equation. Okay, now here this will be perpendicular. Why? Because altitude it asked. Let me call this as AM. Okay, so I'll write AM with the altitude here. When you use the word altitude, it is understood that it's a perpendicular. In earlier exercises, you had a median, if you remember the word median. So in that case, it was a midpoint. So if you are asked for the equation of a median here, we had such question. Equation of median, if you recall, equation of median. There what we had done, we had this midpoint by taking the average, and then by 2-point formula you had got the equation. Here it's not the midpoint. What is this? This is the altitude. So this must be perpendicular. This need not be midpoint. Okay, so now how we'll do this? We want the equation of AM. We find here one of the question is, there are 2 sub question. Equation of AM, altitude AM. Okay, so what you need to get the equation of a line? Slope and point. Point you are already given, this one, x0, y0. You have these 2 points, so get the slope of BC first. Is it? That can be obtained very easily. I leave it for you. So therefore you can write the slope of what? AM. How do I get the slope of AM? By which concept? By which concept? M1 into M2 equals to -1. You can see in diagram they are perpendicular. So you have this concept. Suppose this is 1/3, then this is -3. Okay. Which point you are given? 2, 3. Point is which one? 2, 3. So this represents our x0, y0. Fine. So now you have got all the required things. What? You have a point here. You have a slope here, so therefore you can write the equation of AM. I will not do. Equation of AM. By which formula? Point slope formula. Y minus y0 equals to slope into x minus x0. I explained everything. So we'll get the slope equation of AM. Okay. Now what is the other part there? Length of altitude. That is in fact the first sub question. Now we find now length of altitude AM, right? We want this length. So this much in a diagram, we want this now, this much only, this much. So what is this indirectly? Can you recall? Perpendicular distance of A from the line BC, as per our theory. The one way is you get the coordinates of M and use the distance formula, but that should not be done here. What is the another way? Perpendicular distance of A from the BC, that gives us the length of AM. Okay, so what we need to get first? Equation of BC. So first we get equation of BC, line BC. Why we need that? To get that perpendicular distance. Okay, so there you have 2 points, so you can get the equation very easily. Y minus y0 equals to slope into x minus x0. Okay, I'm finding the equation of BC. Why I'm finding? Because we need to use that equation to get that perpendicular distance. First point here, you can take this as like x1 y1, this is like x2 y2. So y minus y0, so this is plus 1. Slope will find x minus x0, this is 4. What is the slope? y2 minus y1, that is 3, upon x2 minus x1, that is minus 3. I repeat, slope of BC, y2 minus y1. So now I answered this question. y2 minus y1, y2 minus y1. So this plus 3, 1 minus 4 minus 3. Okay. So you have y plus 1 equals to minus x minus 4. So therefore this is plus y, this is plus 4, and this is here minus minus will be plus 4, and this is plus 1, so you have minus 3 equals to 0. This is equation of the line BC. Okay, it's like this. This is line BC, you have point here. We want this AM, perpendicular distance. Okay, so I'll write AM equals to, AM means its distance, equals to small p equals to which formula? As we have used in earlier example, previous example. This formula we already used twice in the previous example. Your line is this BC, you know. Line is BC, and that's why we got this equation. Okay, point you are given. Point is A. What are the coordinates of A? 2, 3. So here in this line, instead of x you write 2, instead of y you write 3, minus 3 upon root of a square plus b square, that is 1 plus 1, 1 square plus 1 square. So you have 2 by root 2, so we have root 2. This is the length of what? That altitude. Length of altitude. How much? Root 2. Clear? This is a nice question again. This much you got. You were not given this ready equation, so I got that equation first, and then I got this perpendicular distance, AM, right? By which formula? This one. Okay? I hope this is now clear to you. Okay, next question now. What about next question? Question number 18. Okay. What it says? P is again length of the perpendicular from origin. Okay. To the line whose intercepts on the axis are this. Okay. So here you are given the perpendicular distance from origin. So 0, 0. What will be the equation of the line? Your ready equation you are not given. Can you just recall? This is a line whose intercepts on the axis as A and B. It is this, x upon a plus y upon b equals to 1. Very standard form. Line whose intercepts on the axis are a and b. This is one of the standard form and different forms of the line. So it's like this. You have a ready line. Now fourth time we are using the same concept. This is 0, 0. You are given this perpendicular distance equals to small p. So we'll use that first. So here small p equals to, that's given, perpendicular distance of origin 0, 0 from the line. From the line, let me write here 1 here, from the line 1. I'll write like this. Okay. So therefore small p equals to which formula? Here. Which formula here? I'll just remind you, modulus of x1, but here this will be 0. by1, which is also 0, plus c. Why this is 0, 0? Because specially you are finding from origin, upon root of a square plus b square. So directly you have modulus c. So here modulus c. What will be modulus c? You see here, this is like ax plus by plus c. So it will be minus 1. 0. Here x is 0 because that's x1. As I told you, y1 is also 0 here, right? This is also 0, and you take this one on the left hand side, minus 1 upon, here what is a and b? I already emphasized earlier, a and b are coefficients of x and y. What's the coefficient of x? It's like 1 upon a in our case, so 1 upon a square. Plus, what's the coefficient of b? 1 upon b, so 1 by b square. Okay, so we, as per the requirement, you see, you don't want the square root, so we'll just square it. So p square equals to, this will be 1 because of squaring, and this will be free from the square root. Why we are squaring? We don't want the square root in the required expression, just by squaring. Okay, and therefore 1 upon p square equals to 1 upon, just take the reciprocal, so you have 1 upon a square plus 1 upon b square. Proved, that's all, just by taking the reciprocal.